So 2, 3 linear function slope-intercept form, slope y2 minus y1 over x2 minus x1. That's good. Next one. So write down the A and B. I'll make it so you can see C as well. And I'm muted. Gotta love technology. Okay, better? Okay, so write those first three down, A, B, and C. We are going to find the slope. One, we'll be able to find the slope. It'll be some number. Could be a fraction, could be an integer. You don't know. Second one, we're going to get either 0 or undefined slope as the possibilities. So we'll get 0 slope and undefined slope and one that actually has a slope. This is like order of operations easy, as in you guys all know the order of operations, you just don't always use it. So we're going to start doing the top one here, y2 minus y1. If it helps you to label these, you can. I never do, except for that very first problem I do. And then we're going to subtract the second y minus the first y over second x minus first x. So the place people screw up on these problems is that minus minus thing right there. Remember, you got the minus in the formula, and if the number is also negative, you have two negatives back to back. When you have two negatives back to back, they make a positive. Okay? So that in the bottom there, and I just like switching it to a positive, use a different color. And then when I'm thinking about the bottom, I don't think about -2 plus 3, I think about 3 minus 2, using that commutative property with addition. Dale? They do go away, yeah. As soon as you multiply that stuff out, the parentheses do go away. So we get -3, 3 minus 2 is 1. You can leave it like that, -3 over 1, totally fine. Or you can just divide it out and get -3. Okay? Sometimes it's helpful, especially when you're graphing these things, to have both the rise and the run of the slope, to have both numerator and denominator. So if you leave it as -3 over 1, no big deal. When we do the second one, subtract the y's, 1 minus 1, subtract the x's, -4 minus 3, like that. So this is the one where you have 0 on top and, in this case, -7 on the bottom. When you have 0 in the numerator and any other whole number in the denominator, that's when you divide to get 0. It's easy to forget that. Like, which one is 0? Is it 7 divided by 0 is 0, or 0 divided by 7? This one's a 0. So when you have a 0 in the numerator, that's when it's 0. You can remember that by just thinking you can't divide by 0. So if you have 0 in the denominator, you can't divide by 0. So that's going to be the undefined one, which will be this last one. Did you have a question, or you did?
Just about 0 at the denominator.
Yeah. That's going to be this one here. So we have 1 minus -3. That's the place where people screw up, so just be careful there. You've got the minus in the formula and the number is negative. Make them both negative. So you can just go ahead and make that switch right away if you want. Negative times negative is positive. And then we're going to subtract the x's, so 7 minus 7 in the denominator. So we get 4 in the numerator and 0 in the denominator. And they will call that, usually in Algebra 2, they call it undefined. They'll also say, just kind of depends, they'll say it has no slope. You can write either one. Remember, like when you take your quiz tomorrow, you're going to choose whichever one the multiple choice answers give you, right? So they might say no slope, they might say undefined, they mean the same thing. So when you look at B and C, you're going to have a little thought moment here, right? Mildly higher level thinking question. I want you to think which one's horizontal, like that. Which one's horizontal, B or C? So just think. Then I want to see, you're going to tell me what you were thinking and trying to figure that out, because that is more important than actually figuring it out. Which one is horizontal, B or C? And you're going to give me the why behind it as well. Anybody willing to be brave and volunteer? Come on. Go for it.
Is it B because -7 is in the run, so it's like going across?
Yeah, that's a good way to think about it. So -7's in the run. Looking at the B, you got a -7 right here. So that means it's running across, right? So that's one way to think about it, totally solid. What I love is when a kid thinks of a way that I never thought of myself. I didn't think of it that way, but that doesn't mean that's not totally valid, right? Anybody else have another way to think about it?
B and C.
Between B and C, which one is horizontal?
She has no slope.
She has no slope. So how do you know if that's vertical, horizontal, or it has no slope?
It's a rise of a run, forced rise.
Force rise.
It's like,
So it only goes up, so it's got to be vertical. That's good. So Garrett started, didn't totally, and I like when students do that, didn't totally know what he was talking about at first and just kind of like reasoned it out in the moment. So that's a good skill, a skill you'll have to practice in future classes and in your adult life. So that totally makes sense. So I didn't think of either of those ways. I'm a visual, like that's my strongest modality, learning modality. So I just made a quick little graph, right, to figure it out. So if I have 3, 1, so I'm out on 3 on x, here's 1, and then I have -4 on x, and I have 1, that one's got to be the horizontal line, right? So that way you can see it, and you're like, yes, I know that's correct, right? Whereas some other ways you might not be as sure, but you can always just graph that line. So to do that same thing on the bottom one here, if we have 7 on x, -3 on y, we have 7 on x and 1 on y, that's going to be your vertical line. So vertical lines have no slope, horizontal lines have 0 slope. So that's just a little quick synopsis of that. Here's an even stupider way. I like to call this my stupid face because it makes me mad. Even like drawing that circle, I'm already kind of angry because I'm weird like that. So I got the eyebrows there. One has a plus, one has a minus for the pupil. The plus one is going uphill, so that's what a positive slope line looks like. The one that's going downhill, that's how I view it anyways, has a negative slope. Downhill, it's going into the crapper, right? Negative. Now that's the way how you can remember positive, negative slope. So we draw that long nose, vertical line, and put a little U under it. That's undefined. See, it makes me mad just seeing this picture on here. And then circles on the ends of the mouth, that represents a 0 slope. So if that helps you, even better, like if I were in my own class learning this, I would draw that stupid face because it made me so mad. I'd be more likely to remember it because it's so stupid. Okay? That's just me.
I remember.
You remember from freshman year? Yeah. So that's good. Alright, so let's get rid of that thing. Now we're on to slope-intercept form. Y equals mx plus b, even learning that forever. I'm going to write it again. So y equals mx plus b, where m is the slope, b is the y-intercept. All you have to do, and I have students that miss this problem on a quiz, and it makes me so sad. So they tell me that m is 1/5. All you're doing is plugging in 1/5 for m. They tell me that the b right here is -3. So we plug in -3 for the b. That's it. You're done. No math, just plugging in. Making sure you know what's what. That will literally be a problem on your quiz. Please don't miss that. Because it's very easy. Right? Nod your head at home if you find that very easy. Yes, it's very easy. I move around, don't worry. So they won't always say like 0, -3 is the b. Sometimes they just say b equals -3. It's even easier than if you ask me. Okay, write these two down. I'll give you a second. These problems are in what's called standard form. Standard form is this. Ax plus by equals c. So you always have the number and the x, the number and the b equals, and then just the number after the equals. So we're switching from standard form to slope-intercept form. So if we're switching to slope-intercept form, I want the y on the left by itself, and all of the other crap on the right side of the equal. So to do that, we subtract 5x from both sides. And we get -4y equals -5x plus 16. So many of you, because you see the 16 right here is before the 5x, write the 16 first, but then it doesn't look like y equals mx plus b. So make it look like y equals mx plus b. When you graph these things, it won't confuse you. The last thing we have to do here to get the y by itself is to divide each and every part by -4. So show that thing divided out 3 times, please, I beg you, because you lose points if you don't. You'll lose points only because you don't reduce the fractions correctly, because we have to reduce the -5 over -4 fraction and 16 divided by -4 as well. If you only write one -4, you're likely to forget to reduce both. So this thing looks like this. Y equals, these negatives right here just cancel. So you get 5 over 4x. And then 16 divided by -4 is -4. So I always have a couple of kids that will write like positive divided by negative. They'll write right here. They'll write plus -4. Don't do that. I take points off. You didn't simplify, because what's a positive times a negative? That's a negative, right? So just write negative. Because if you have to do another step after that, it's not confusing that way. So that's one of those problems, going from standard form to slope-intercept form. Now, this next one, we got a bunch of fractions. Okay? So how do you deal with fractions? I could do this problem in, I don't know, a bunch of different ways, but 2 main ways. I can add 3/4x to both sides, and then multiply it by 2 to get rid of that 1/2. I find it better to just get rid of all the fractions right at the beginning. It's just, I think it's easier. If you want to add the 3/4x and multiply by 2, more power to you. So if I want to clear these fractions, I need to think about this concept of least common multiple. So does anybody know what a least common multiple is?
Smallest number that goes into all of them.
Smallest number that goes into all of them. So that would mean, by your definition, that the least common multiple here would be 2. So if I multiply everything by 2, do I clear the fractions? So what do I have to multiply by to clear the fractions? We're having a thinking moment. It's okay. What do I have to multiply by to clear all the fractions? I'm multiplying by the least common multiple of 4 and 2. Come on, I know somebody knows. At home, anyone? Peanut gallery at home, anyone? Not a single one, huh? Okay, so I start with the 2 denominators I have, 4 and 2. So multiples of 2, 2, 4, 6, 8, 10. I just did multiples of 2. Multiples of 4, 4, 8, 12, 16, 20, 24, like that. Those are multiples. So I think like 1 times 2 is 2, 2 is the multiple. 2 times 2 is 4. 4 is the multiple. So if I do multiples of 2, as soon as I have the same two numbers, that is the least common multiple. So I didn't need to go too far on this one. So if I multiply each of those terms by 4, then I'm going to clear all the fractions. So I'm going to put this whole thing, even including across the equal sign, in parentheses and multiply by 4. And I'm going to show more steps right now than you need to show, but I find that students understand it better if I show all these steps. So I'm going to show that 4 multiplied in front by negative 3/4 x. So that's just the first term multiplied by 4. Actually, let's put that 4 in a different color. So then we have plus, we're multiplying by 4 again. This time we're multiplying by 1/2 y. That equals multiplying by 4 again. And here we're multiplying that 4 by negative 1. So how do you multiply a whole number in a fraction? Well, you can make that whole number into a fraction if that helps you. So I can put 4/1 for all three parts. When I multiply fractions, I multiply straight across, top and bottom. Okay, so that's one way you could do it. I could multiply right here. 4 times negative 3 is negative 12. Divided by 4 is negative 3. Easier, in my opinion, is to do this. So if we just cross off those 4's, because 4 divided by 4 is 1, right? Then we have negative 3x left. So again, I can do the same thing here. 2 divides into 4 2 times. 2 times 1 is 2, so I have plus 2y. 4 times negative 1 is negative 4. So now all we did is get rid of the fractions. Now we can get it into slope-intercept form. So again, I find students like clearing the fractions more than any other method, so that's why I show that method. If I were to do this problem myself, I would add 3/4x over both sides and multiply by 2. It'll get to the same place. So if you think that's easier, go for it. Totally fine. We're going to add 3x to both sides. So now we're in standard form and we're switching to slope-intercept. In slope-intercept form, you want the y by itself on the left side of the equal sign. The last step I have to do now is just divide by 2. Again, show that divide by 2 for each and every part of the equation. So we have y equals 3/2x minus 2. Question, Melody.
So how did you get the multiple thing again? Like the 4 on the top? I got how you got the, that
Yeah.
multiple thing.
So right here.
Yeah.
So I want to just continue to multiply those numbers until I get to the same number. So 2 times 1 is 2. 2 times 2 is 4. And already I've got the same number, 4 and 4 right here. Right, so if I did least common multiples, let's just go to a new page real quick just so we can explore that concept real quick. Let's say I had 3 and 4, and I wanted to know what the least common multiple is, so I do multiples of 3. 3 times 1 is 3, 3 times 2 is 6, 3 times 3 is 9, 3 times 4 is 12, 4 times 1 is 4, 4 times 2 is 8, 4 times 3 is 12. So the least common multiple of 3 and 4 is 12. Okay, so that's all we're doing there. No big deal.
Okay, so you got the numbers, you just got the numbers from the fraction?
Yep, you take the denominators of the fraction and then just do the multiples of those denominators. Now you realize I could have just multiplied 3 times 4 and got 12. So you could do that as well. That's another option. Sometimes you end up with massively huge numbers that you may not anticipate, so the multiple thing is the best way to go. But you can always just multiply the two denominators. Yeah,
Okay, thank you.
yep.
Well, 4 times 2 is 8.
But 2 times 1 is 2, 2 times 2 is 4. So now I already have it in common.
I thought you were saying it would work like no matter what, like it always works, like 3 times 4 is
I could do 4 times 2 and multiply this by 8. And then the only difference that would happen is these things would reduce down here. You'd have fractions that would divide out and reduce further. So you can do that, multiply by 8, still works. Right, but there we go. So y equals 3 halves x minus 2. Okay, so now we have 4 more slides. So we're going from standard equation, standard form of a linear equation to slope, intercept, and graphing. We'll do that twice. And then I'll give you graphs, and we'll go the opposite way, from the graph to the equation. So if I look at this thing, I need to get it into slope-intercept form. I do that by adding 2x to both sides. And it's already in slope-intercept then, which is handy. So we just have y equals 2x plus 1. And I can graph this thing now. Raise your hand at home and in person if you have graph paper. Like in your house, anywhere, like you own graph paper. Okay, bring graph paper to math class. We are going to do so much graphing this year. If it were me, I would just buy a graph paper notebook and take my notes in there. Like that's how much graphing we do. Plus it helps stuff stay organized. So yeah, buy graph paper, get graph paper, please. So to graph this line, we start with the b, right? So we're thinking y equals mx plus b. So you start at the b. In this case, it's positive 1. So the b is the y-intercept. It means where it crosses the y-axis. So we start there. If you need the rise and the run of the slope, you can put that 2 over 1. So from this spot right here, we go up 2, right 1. Up 2, right 1. Sometimes you run out of room on your graph and you also have to go down 2, left 1. That can happen as well. No big deal, you just count the opposite direction. And then draw your line and we're done. Okay, so start at the B, do the rise over run of the slope 2 times. So we want 3 total points. That third point's just like a built-in double check. In case your line's crooked, you know you counted wrong somewhere or you screwed up somehow. So usually you just count your slope wrong. So that's that one. So I'll give you like a minute. Do this one on your own. Switch it into slope-intercept y equals mx plus b form and graph it. And I'll start graphing it here in a minute or 2. All of you at home and in person, have a drink of whatever beverage you have. In my case, it's coffee right now. Drink water. It's so easy to forget about drinking water with the mask on. Drink more water.
Also the fountain don't work.
Is what?
Also the fountain don't work.
I know, the fountains don't work. So bring a water bottle when you come in person tomorrow, all you at home people. Don't forget to take your little hand raising down, Melody. Thank you. We got one person taking notes on an iPad in here. Super cool to take notes on an iPad. I would definitely buy an iPad, take notes on an iPad. It'll make you so happy. You can do such cool things, especially if you're artistic at all. If I ever have to quarantine, I'll be writing the notes on an iPad. So I use mine like crazy for a ton of different things. Yeah.
For a range problem, we went from negative 2x plus y equals 1 to y equals...
Are you talking about the previous example? Yeah? Okay, sure, show me over here.
I was just trying to do...
Oh, you're trying to, so subtract first, and you can't combine these, so write that x next to the 4, and you can't combine the 14 and the 4x, because the 14 does not have an x.
Oh, I thought you could do that because you did it so much.
I did. So we have 2x plus 1, 2x plus 1 plus 1.
So I was confused because like you say like you can't add like a number with an x
Right.
to a number with I.
So scribble out your 18 and instead write 14x plus, or 4x, sorry, plus 14. Here, I'll show you. Put your virtual hand raising up when you're done, just so I know.
I was just confused how you're able to add a number with x to 1.
I didn't.
Oh, you didn't?
2x goes right here, 1 goes right there. Okay? So when you subtract 4x, you have negative 7y, right that? Negative 7 in front of that.
Oh,
Like
you
this.
didn't.
So, we got most of the hands up. I'll just show you here. It'll be easier. So we subtract 4x from both sides. So we get negative 7y equals negative 4x plus 14. That's your question. To see the furrowed graph. Making sense? A little more?
No, I get it now.
Okay.
I don't know how to graph it, but I get it.
I'll show you. That's my job, man. So we're going to divide by negative 7, all three parts. I guarantee there's one of you punks at home who showed me divide by 7 with the big fraction bar. Don't you do that in person, right? Show the divide 7 for each part. You get more of them right. So y equals the negatives cancel here. So we get 4 over 7x. Positive 14 divided by negative 7 is negative 2. So when you start your graph, you go start at negative 2, and I count up 1, 2, 3, 4, write 7. So I'm going to do down as well. Especially when you count out a bigger slope like that, you might be off one. So just double check, make sure your dots are on a line, and you good. You good on the graph? Okay, good. So I started at negative 2, boom. I go up 4 and write 7. So from here, I counted up 1, 2, 3, 4, write 7. Now if I count up 4 and right 7, I can also count down 4 and left 7. So that's what I did for that bottom point. Right? Because 4 over 7 is the same thing as negative 4 over negative 7. Right? So that's why I can also go down and to the left. Okay?
So that's why you're under the...
Exactly. Exactly. Okay, so I'm going to do one. I'm going to give you a graph, and then you're going to come up with the equation. So here we go. So how do you do it? So this one, I'll tell you the points. So I started at -3. So I'm just going to write y equals mx plus b. So I start, the b part's -3. So just plug it in right below the b. And then I just count out my slopes. So up 1, 2. So that's a +2. And a +3. Remember, you always have to have the y on top. So 2/3, not 3/2. So y equals 2/3 x minus 3. So get the y-intercept first, then just count out your slope. You need to think about the direction you're going, right? I'm going up, so that's positive. I'm going to the right, that's positive. Okay? The last slide, then we all get a mass break, yay. Don't have the line tool. Try that again. So I start at +1. So I know it's not that easy to see in the back there. So okay, that's at 1. So when you're doing this on your own, you're doing it on your own. Right? Y equals mx plus b. And plug in the component parts. Put your virtual hand up online when you're done. And I can tell in person because you'll stop writing. Many of you are done already, fast. I like it. Lexi, what's B? You are correct. How about the slope? -3/4. So -3/4 x, y equals -3/4 x. Could I write 3/-4x? Is that okay? So here's the question. Does that equal the same thing as that? Yeah. They're all -0.75. So it doesn't matter where the negative goes. Down low, up top, or right next to the fraction bar. They're all the same thing, okay? We've said that before, I'll say it again because it confuses people.
What if it's on both sides?
Huh?
No.
If it's on both, then it's different, right? Because the negatives cancel, and then it's no longer negative. Okay, let me stop the recording while I actually remember.